Some problems we're asked to solve will ask us to use Pythagoras more than once. In other words, you may need to use it a couple of times within the same question. If we look at this problem here, we've got two triangles. In this first triangle, we have the x. This is what I'm trying to find. Now, it is a right angled triangle, so I can use Pythagoras' theorem, but to do that I would need to know this shorter side and the length of this hypotenuse here, which I don't have. So what I'm going to need to do instead is find the length of the hypotenuse here using this triangle, which I do have enough information. Again, this is a right angled triangle. So drawing out the first triangle that I'm going to use, which is this one I've shaded in blue at the bottom, with 8 and 4 centimetres. And we'll call this y because x has already been used in the question. What we can do is say, well, this is a hypotenuse question. So y squared equals 4 squared plus 8 squared. Y equals square root of 4 squared plus 8 squared. Remember, typing this into your calculator, ideally put brackets around the 4 squared plus 8 squared, and that comes to 8.94 centimetres. And this 8.94 is now the length of this hypotenuse, which will help us with the next part of the question. So what I'm now going to do is I'm going to now draw out this triangle here. It doesn't need to be perfect. So let's see, x 6 centimetres, and what we found out from here, this 8.94 can go there. And then what we're looking at is, what am I trying to find, hypotenuse or shorter side? Now, the right angle's here, so 8.94 is the longest side or hypotenuse. So this x and this 6, these are my two shorter sides. I'm trying to find a shorter side here. So again, write out shorter side. So x squared equals, and remember on a shorter side question we're going to be doing subtraction, so 8.94 will have to go first, that's squared. Take away 6 squared, x equals the square root of all of that. Again, use your brackets there. 8.94 squared, take away 6 squared, and type it all into your calculator, brackets and all, and that's going to give us 6.63 centimetres. In this next example here, we still have two right angled triangles. It is a slightly different style of question. So the first right angled triangle is this small right angled triangle with 14 and 9 on it, and the second of the right angled triangles is this larger right angled triangle going around the outside here. So what we need to be able to do is use both of them. The important part about this question is realising if I'm trying to find the length of x, I'm going to need to work out the length of this side and also the length of this side, and x is effectively the difference between the two sides there. So the blue side in this case, subtract the red side, will leave me the value x. So we can start with either triangle. I could draw out the small or the large triangle first. I'm going to draw out the larger of the two triangles first, which I've used blue for, so I'll stick with that. And I'm going to put maybe y at the bottom of here for my length. X is already used elsewhere in the question, so I'm going to avoid using that again. 24 metres up here and 14 here. Now we put a right angle in. Remember, a right angle will help us find the hypotenuse if it's not already very obvious. In this case it's quite obvious. 24 is the hypotenuse, so the 14 and y are shorter sides, so I'm looking for a shorter side. So in this case, y squared equals 24 squared, take away 14 squared, and again, usual Pythagoras process from that point onwards. Square root of 24 squared, take away 14 squared. Typing that into our calculator, we should get 19.49 metres. I'll then move on to find the red length, so we'll just quickly sketch out the smaller of the two triangles here. And again, putting a right angle in. 19 opposite the right angle there means 19 is the hypotenuse. 14 still on this side, and we'll use maybe z for this third side. Now, again, z is one of the two shorter sides, so we'll quickly find that. Remember, shorter side, writing this out is just really a memory aid to remind you to put a subtraction in the middle of the Pythagoras problem here. So z squared equals 19 squared, take away 14 squared. Z equals the square root of all of that, which should come to, in your calculator, to 12.85. Now, remember the length of x is the blue length, which is the full length of the bottom of this large triangle, but subtract this red length here and that will leave us with x. So to finish off, we've got x equals 19.49, take away 12.85, which comes down just to one decimal place, 6.6 meters.